Hello, welcome to Dash Excel. Today we're going to explore Excel's methods of looking up values in data tables. This is a common task in consulting, banking, and other corporate roles that everyone using Excel must master. So, here we have a data table of employee data. There's many lookups we could perform here, but let's focus on finding the location where one random employee works. For example, Daniel Thompson. So here we've selected Daniel Thompson. We make it an absolute reference by hitting function F4. And now we want to identify the location where Daniel Thompson works. So, we can see this in the data table up above. We can see that it's Atlanta. However, by just hitting equals Atlanta, that doesn't really work, because if we were to drag that down, then Miami does not line up with Olivia Martinez. So we need to actually use a function. There's several lookup functions that Excel offers. And here are basically all the definitions of those functions. The first is index match, which is very commonly used. Then there's lookup, vertical lookup or VLOOKUP, horizontal lookup or HLOOKUP, and XLOOKUP, which is a rather new function that Excel's developed that sort of replaces the functional use of these other three lookup functions. And lastly, filter, which operates rather differently from these 5 other functions up above. But we'll explore the use of all 6 of these functions or combinations of functions in this video. So let's start with the first function, or I should say combination of functions, index match. We're going to start with the match function, and ultimately we'll be putting that inside of the index function as an argument. The fancy word for that is nesting. So we're going to start with the lookup value, which is Daniel Thompson. We're going to input our lookup array, which basically is the list of all employees. And then the match type, this is an optional argument that's indicated by the brackets in Excel. In most cases, you're going to either leave this blank and it will default to 0 for an exact match, or you can specify 0. Here we're looking for an exact match. However, there are these other options. If your data was sorted in an ascending fashion, so alphabetical ascending, you could use 1, meaning find the next value that was alphabetically less than Daniel Thompson. If your data was sorted descending, you could use -1, finding the value that's alphabetically next greater than Daniel Thompson. For our purposes, we're interested in an exact match, so we'll keep it at 0. So when we hit enter, we can see that this returns a value of 7. Why 7? Well, because Daniel Thompson is on the 7th row of our data table here. And you can count it down from employee name and see that it is the 7th value. So that's basically what match does. It returns the position in the array, or vector in this case, because it's a single column. So now we're going to input the match function inside index. For index, we want to select the array that's the target array, so the location. And then we want to specify the row number. Well, we know the row number, it's 7. We just used match to calculate it. And lastly, we have column number. Because there's only one column, we don't actually need to specify anything here. It's an optional argument. And because it's an optional argument, we can just close the function, hit enter, and we can see that Atlanta is returned. If we wanted to be really complete, we could put 1 for the column function, and you can see that Atlanta is still returned. Why 1? Because there's only a singular column, so we're telling Excel to select the first column. If our target array was bigger, say if we had selected 3 columns, then we would have to input the column number, and that would be 1 here. if we wanted to look something else up like salary from this array, then we could adjust it to 2. And there we get salary. But we're interested in locations. We'll keep it as 1. If we were interested in returning, say, multiple columns, or all the columns in the selected array, then we could replace it with 0. And that would return an array function. And as you can see, all 3 values, location, salary, and bonus, are returned. But we'll keep it at 1 because we're just interested in the location for our purposes here. But that's a helpful trick with indexes. 0 will return all the values in the assigned row. So just using a formula text formula here so that we can keep track of what these formulae look like. And next we're going to look up the lookup function and see how this works. Now, the thing about this lookup function that makes it very uncommonly used and really kind of deprecated within the Excel space is that you need the data to be sorted ascending, in this case alphabetically because we have text string data. Because our data is not sorted ascending, we're going to pass on lookup and instead focus on VLOOKUP. This is a vertical lookup function. The tricky thing with VLOOKUP is that you need to ensure that your lookup array is the first column of your table array. So in this case, we're going to select the table, but we're going to avoid employee ID because we're looking it up by employee name, which is this first column, column B. So we have to start the table array at column B. Next, we're going to select the column index number that we want to return data from. In this case, it's location. So we can see that this is the 1, 2, 3, 4th column. If we want to be a little bit more dynamic about it, though, we'll use the match function to search which column number location represents. So you can see I've done that here. And we're looking for an exact match, so we'll input false. And as you can see, we get Atlanta once again. And you can see by highlighting the match part within this that it returns the number 4. You can see that just by highlighting the argument inside the formula tab in Excel. And that's basically VLOOKUP. So now we can do HLOOKUP. HLOOKUP is actually not very commonly used. VLOOKUP is much more commonly used, and you'll probably see why in a second. But for the sake of completeness, we'll go over the horizontal lookup. So because it's a horizontal lookup, instead of looking at the first column for the table array, we'll be looking at the first row of the table array, which means that the lookup value is actually not Daniel Thompson, but the word location. So we select location for that. And then for table array, we're going to highlight the same region as we did for VLOOKUP. And now we need to specify the row index number. So the row index is where Daniel Thompson is. Now we know that this is 7, so we could write 7. But again, we want to be a little bit more dynamic so that we could drag this formula down potentially and use it across multiple values. So we'll use the match function to find Daniel Thompson again. And again, we want this to be an exact match, so we'll input false for that last argument. And as you can see, we get Atlanta again. So next we're going to look at XLOOKUP. And let me just drag these formula texts down so we can keep track of the formulas that we're building. Now for XLOOKUP, it basically is a more modern function that Excel has built to replace the need to use lookup, VLOOKUP, or HLOOKUP. So let's see how this function works. We have a lookup value, Daniel Thompson, a lookup array, so fairly standard, similar to what we've been doing, a return array, which is our location data. And then if not found, I usually just write not found. You can put any kind of text or other function in that argument. We're again going to look for an exact match. The great thing about the XLOOKUP function, though, is that it does not require the data to be in ascending or descending order. It does not require it to be sorted. So if you wanted to use -1 or 1 to find, like the next lowest or next highest alphabetical value or numerical value, if we were working with numerical data, then XLOOKUP is a very powerful function for that because you don't need to sort the data. It will automatically find it. But for our purposes, we'll stick with an exact match. And then the last argument here is just how you want the function to search. So we're going to do search first to last. You could also do last to first. Because all of our names here in this data are unique, it would return the same value. And then the binary search options at the bottom there are really just if you're working with like tens of thousands or hundreds of thousands of data points where you need the search to become more efficient, then you could use binary search, and that would require the data to be in either ascending or descending order. But for our purposes, we're just going to do search first to last. So we'll close our function, hit enter, and you can see once again we get Atlanta. And lastly, we're going to look at the filter function. Filter function works pretty differently from the other lookup values that we have here, mainly because it has the ability to return multiple results if there were multiple Daniel Thompsons in our data table, as opposed to the other functions, which would simply return the location of the first Daniel Thompson. Or if we were using XLOOKUP, you could specify the last Daniel Thompson. So here for array, we specify our target array, which is location. And then we want to include all the places where employee name is equal to Daniel Thompson. And then if we don't find any, we can just write not found. We'll close this function off, hit enter, and we get Atlanta once again. Now say, for example, we had multiple Daniel Thompsons. So we'll override Olivia Martinez with Daniel Thompson. We can see that the filter function has automatically returned us now 2 values, Dallas and Atlanta. And as you can see, that lines up with both Daniel Thompsons in the data table. And as you can see, the other functions have all switched to Dallas now, because the first Daniel Thompson is in Dallas and not in Atlanta. So I'll just undo that right here, and yeah, that basically, there you have it. These are the 6 main functions that you can use for looking up values in Excel. Now, we're going to do a little exercise here where we try a different approach to coding these functions. So I'm just going to copy this worksheet. So now we have the exact same worksheet that we built before, but this time what I want to show you is how to use this with tabular data. So we're going to select all of our data. That's Command A on Macs, Control A on Windows. Then Command T on Macs, Control T on Windows to turn it into a table. So we'll hit OK. Excel automatically identified that our table had headers, so we just approve that. And as you can see, the formulae have not been updated to account for the fact that this is in a table. They're still in their normal cell references. So we basically need to delete these formulas and rewrite them for the table. Now, why is this somewhat more useful than the other way? Mainly because with tabular data, if you expand the table, if you were to expand or contract the table and add or delete more people, then that's automatically incorporated into the formulae ranges. So you don't need to update the formulae every time you update your tabular data, basically. So yeah, you'll just see me update these formula for the table as we go through it. And there we go. We end up returning Atlanta again with index match. And as you can see in the formula for index match, it's now calling this table, which is called table 2. It's calling the specific column headers, location, and employee name to find what we need. And now we're going to repeat the process with vertical lookup function VLOOKUP. You'll notice that as opposed to before where I was highlighting the full table including the headers, I'm now only highlighting the table without the headers. You could, optionally include the headers, but I just find it makes for a clunkier formula, so I don't do that. Okay, a little bit of an error there. One too many parentheses, so we'll just delete that extra parenthesis. And now HLOOKUP. Here we need to select the headers because, again, HLOOKUP is looking for the first row, and the first row includes the word location, which is our target column. So we do have to include the row names here, and you'll see the syntax for that. You can automatically generate in Excel by highlighting the appropriate fields, but it's that #all that incorporates the headers for a particular column when you're working with tabular data. Next, XLOOKUP. Here we can go back to just highlighting the columns themselves without the header cell in the selection. We'll be using exact match, searching first to last. Once again, we return Atlanta. And lastly, filter. Now, as I was previously mentioning, the great thing about these formulae is that you don't need to adjust them when you add data. So say, for example, we were to add another person to this data table. Let's call him Miles Clark. And we can put him in New York. So now if we update our employee name that we're looking for to Miles Clark, we can see that it shifts to New York. And we don't need to change the formulas at all. Conversely, we'll just undo that for our purposes here. Conversely, if we were to add Miles Clark here in our unstructured data table, that's not in a table format, and search for Miles Clark, it would return an error because Miles Clark is outside the range that we had previously specified for these formulae. Now I want us to try a little exercise here. So imagine, that we're a teacher and we have all these test scores for our class. And we have 15 tests that are labeled tests 1 through 5 that are broken out per semester. This is a 3-semester school year. And we want to be able to locate any test score for any student, for any test, for any semester. So we have this drop-down list of all the students. This is sorted alphabetically. The way I did that is I used the data validation list option and then specified the range of A4 to A34, which is basically all the students plus the average value at the bottom. So I'll just hit OK. So that's the student drop down here. So let's say, for example, we want to find, a score for Amelia Ward. And let's say we want her test score from semester 2, and let's say the 3rd test. So what's the score here? Well, we need a formula to figure it out. So we could see, visually on the table that it should be 39. So we could very lazily just, hit equals 39, and that would work for this, one specific person. But that's not, very dynamic. As soon as we change the test or the semester or the person, then 39 is no longer true. So we need to build a formula. So as we can see, we have a data table here. It's 30 rows by 15 columns, so 450 total values. And it would be a pain to have to visually scan through 450 values every time you want to find one score. So we're going to build a formula for it. I personally prefer index match for my lookups. So we're going to use index match. I think it's probably the most versatile option. There's some instances where I would use XLOOKUP over it, but in this case we'll use the matching function to first identify the test score. So this returns 3. Now you might already be thinking, well, you can't necessarily do that because there's multiple values that say test 3, and there are. So this is returning just the first value that says test 3. That's problematic because we're looking for semester 2, which is the second value that says test 3. So how do we locate that? Well, we basically need to make it so that our data is unique, such that every value is unique. And how do we do that? Well, to sort of show you my thought process here, if we were to combine the semester name with the test name, that would basically create 15 unique test names, because once you combine each of those semesters with the test name, then they all are representative of unique tests. So that could be one approach that we use. I prefer a different approach. So I'm going to insert some helper rows here. And you'll see where I'm going in just a moment. So we're specifically looking for semester 2, test 3. So we start with the tests. And we can see we have tests 1 through 5 repeated 3 times. So we can do equals and then select this array and hit equals and then our target value here, which is test 3. And this creates an array of trues and falses. And what that's known in computer science is as a Boolean. Boolean just means basically an array of ones and zeros, or trues and falses. And we're going to repeat the same thing up here for the semester. Great, so now we have 2 Boolean arrays of trues and falses. We can see that semester 2 is highlighted true, and on the bottom one for test 3, anywhere where it says test 3 is true, and wherever it says something other than test 3 is false. So now we can use a little bit of matrix multiplication here to multiply these 2 Boolean arrays together. And it may be a long time since you've done linear algebra and matrix multiplication in school, but basically when you take 2 vectors that are consisting of ones and zeros that are of the same size, and you multiply them together in Excel, you're multiplying basically a bunch of zeros by ones. So anywhere where there's 2 ones that line up, you'll have a 1, and anywhere where there's a 0 and a 1, you'll have a 0, and a 0 and a 0 will also return 0. So as you can see here, we've multiplied our 2 arrays together, and it's returned a new array that's 15 cells long, which looks good because we have 15 tests. And there's only one value that's 1, and that represents our semester 2 test 3 score. And you can see that's the case because that's the only place where both arrays are true. So now we can put this back inside our match function, and we're going to search not for the value of test 3 or semester 2, but the value of 1, because the array that we're actually searching through is just a Boolean of ones and zeros. And the reason that it's not true or false is because anytime you perform a mathematical operation on a true or false array in Excel, it converts it into ones and zeros. So that's just a helpful thing to note. So we'll be searching for 1 here. And again, we're looking for the exact match, so we'll input 0 there. And we'll hit enter. And as you can see, we've now returned 8, which is the correct column in our data frame that we are looking to find. As you can see, it's 8 columns over. So now that we've identified the correct column, We can delete these helper rows. We no longer need them. I think they've shown our methodology fairly well. And now the next stage is we've found the column number. We need to find the row number. And the row number is going to be given by the student name, because the student names are in column A and they denominate the individual rows. So we can visually see that Amelia Ward is in the third column. But to do this dynamically, again, we'll use another match function, searching in our array of student names, and we can include average in there as well. And we can see now that the match function has returned, indeed, the third row. So that's correct. So now it's a matter of combining these two match functions into index. Remember, index is how we locate a specific value given a row index and a column index. That's why it's called index. So we'll highlight our entire array here. And select our row and column index. And as we can see, this returns 39, which is correct. But right now, we very awkwardly have this function spread across 3 cells. So we're just going to do a little bit of work to consolidate this all into one cell. And we can just do that by copying and pasting the formulas and inserting them into the index value. So you'll see me doing that here. This is a little tedious, but it'll ultimately make the formula fit in one cell and look fairly professional. Great, so now we have it in one cell. It returns the number 39, which is correct. And we'll just copy and paste this into the cell that we want it to be in, which is next to the score value. No. There we go. 39. So, if we want to test if this function is really working, we can select another person, perhaps Elijah Brooks. We'll look at semester 3, and we'll pick test 5. And now we have a new number, 77. So let's visually see if this is correct. So we go to Elijah Brooks, semester 3, test 5, 77. Great. So it seems like the function is working correctly. And that wraps up our tutorial today on the major lookup functions in Excel, from VLOOKUP to index and match and filter. Now you have a solid understanding of how Excel lookup functions work and how they can save you hours of manual searching and data entry. So if this video helped you out, don't forget to like, subscribe, and check out our next tutorial for more Excel tips and tricks.